Good morning, students. Welcome back. Today we'll discuss about homologous series and functional group. In our last class, we had discussed about the different types of organic compound. Yes or no? So today I'll give you the brief idea about homologous series and functional group. Okay. So let us first discuss homologous series. This homologous series is very easy actually. As you all know, this is methane. Yes or no? Okay, let me write C2H6 or let me write CH3CH3. This is ethane. Propane. Butane. Yes or no? If you see this type of series, okay, now from here to here, sorry, this is CH4, from here to here, from here to here, in each successive case, there is a difference of CH2 unit. Okay, so once you move down from methane to ethane, then there is a difference of CH2. If you add CH2, then it will be C2H6. If you see this and this, there is a addition of CH2. Again, there is further addition of CH2. So each successive compounds are differed by CH2 unit. Yes or no? So this type of compound, okay, in which I'll give you the example. CH3OH, CH3CH2OH, CH3CH2CH2OH, CH3CH2CH2CH2OH. So all these are alcohol, as you all know. This is ethanol, propanol, butanol. This is not. So this type of series of compounds with same functional group, if differed by one CH2 unit, so this type of series of compounds are called homologous series. Very easy. Homologous series, successive layer, there is a difference of CH2 unit. Got it? In a simple way, you can easily understand this. Now, after doing this homologous series, let us move on to functional group. This functional group is very important, and you have to understand. Since CH3CH2CH3, this is propane. Okay, this is propane, and in this propane, if one H or any of the H from this particular propane is replaced by, suppose, let me write A. Okay, so the property for this now new compound, after addition of A, this will be new compound. So the entire property now will be different from the previous propane only, like this. Is or no? So now it has different properties. For that reason, A, that is FUNCPIO, functional group. So functional group may be defined as a group of atoms or atoms providing, or you can don't write providing, determining, let me write, determining spatial properties. Okay, so the functional group are the group of atom or atoms determining spatial properties. Okay. For example, CH3, CH2, OH. Now this OH is added after replacing one hydrogen from ethane. This is ethanol. So now the property determining factor or the property determining atom or group of atom is this OH group of atom, that is alcohol. Yes or no? So this type of group of atom or atoms only providing or determining special properties of a compound are called functional group. Okay, so functional group is in a simple way you can understand like this. Functional group are the atoms or group of atoms which provide special properties. Simple. Okay, properties providing factor is functional group. Very simple. Correct? Okay. So once understanding the functional group, you need to know the types of functional group which you have to study. Okay. So in your higher classes, you have to study so many functional groups. Okay. So I'll give you some basics functional group. Alcohol functional group. Okay. So the formula is OH. Aldehyde CHO. Halogen functional group is also there. Generally we write X, so X may be FClBrI. Okay, halogen functional group. Next up we have ketone functional group. Very simple. This is C double bond O dash. Okay. Now, don't get confused with this aldehyde and ketone. I'll show you the difference. See. So this one. You can see same type of structure here. But if one end of the carbonyl carbon, we can call it carbonyl carbon. If one end of this carbonyl carbon is attached with H, okay. If one bond is fulfilled by H, then it is called aldehyde. Remember this. This is aldehyde. One side H, aldehyde. C double bond O. One side H, aldehyde. If both the end is satisfied by C carbon only, then this will be ketone. Okay, if one side C, another side H. Now one side H is there, so once you see H attached with this C with this double bond, then this will be aldehyde. Okay, so ketone both the side C. That is why we have written C double bond O dash. Okay, this is bond. Now next, carboxylic acid. The formula is also very similar. Look at the board. C double bond is there. Now here OH is there. This bond is attached with this OH. So generally we write COOH. This is carboxylic acid. Okay, so these are the functional group which we have already finished in class 10. Okay, so now I am going to add more functional group and try to keep in mind the formula. Okay, ether functional group. Okay, this is O attached, ether functional group. Ester functional group is CO. Okay, will be like this. COO. That's like this. This side without H, anything can be there. Okay. After that, nitro group is also there. This is NO2. Okay, the formula is this is NO2. Okay, this is called nitro group. Another is there, mine. This is NH2. Okay, so another is also there, cyanide, CN, CN, or you can write C triple bond and like this. Okay, so these are the functional group which you have to study. There are more functional group. Okay, I'll give you a chart as I've already provided the chart for you in WhatsApp. Do check that and try to understand or try to know all the formulas. Okay, you guys can thought of this and relate this to the PDF given. Okay. Now, okay, of this. After knowing all this, let us directly move on to IUPAC naming. Okay. IUPAC, International Union of Pure and Applied Chemistry. So the chemistry is actually governed by this international body, governing body. Okay. So and if you develop one compound, if you want to name that compound, you have to follow or you have to take suggestion from IUPAC. Okay, try to find. Okay. So now let us move on to IUPAC naming. Very simple. If you know the basics, you can easily write the name. Okay. So I'll give you. I've already provided PDF. Go through that and try to relate that PDF with today's class. Okay. So that you have to know some rules regarding IUPAC naming. So the first rule is number 1. You need to select the longest chain first. Selection of longest chain. Okay. I'll give you. You'll do with examples. Okay. This is examples. Look at about selection of the longest chain. Longest continuous check. Longest continuous chain. Okay. So if I select this chain, look at this. This is a chain. This will be 1, 2, 3. So I cannot select this chain because it is not longest as compared to this. If I select this chain, look at the word. 1, 2, 3, 4. We have 4 carbon atoms in the chain. So this is the possible longest continuous chain for this given compound. Yes or no? So now number 2. This number 2 is also very important. So in this rule number 2, you need to number or numbering. numbering of selected chain. The chain which you have selected, now you need to number. So this numbering, from which side you have to number, is very, very important. So you have to number from that side, from where you get the lowest number for substituent or functional group. You need to give lowest number for substituent or functional group. Okay, so now simply if you write the chain like this, then this chain should be this, but this one H is now substituted by CH3. Yes or no? So this is substituent group. Here functional group is not there, but here we have substituent. After substituting one H, the CH3 is added to this carbon. Yes or no? So now you need to select the longest chain. You have already selected. Now you need to number from which end. Okay, let me number from this side. Okay, 1, 2, 3, 4. If I start numbering from this end, so this substituent group is getting number 3. Okay, so now I can number this chain in this way also. 1, 2, 3, 4. So if I start numbering the chain from this, from right to left, then this group, that is substituent group, is getting the value 2. Yes or no? So here 2 is smaller than 3. So if I number from this side, then this is getting the lowest possible value. Yes or no? For that reason, so the correct way of numbering is this. Okay. So after numbering, what you have to write? You have to write the prefix, then root name, then suffix. Remember this. Prefix, if substituent group and another functional group are there, then you need to write prefix. Okay, then root name, then only suffix. Okay, this is the way of writing IUPAC name. Okay, now look at the board. Here we have this CH3, that is substituent group. So this prefix is for substituent group and halogen functional group, very important. Okay, for halogen and substituent group we write prefix. We'll do examples later also, but look at this example. Now here you need to give number, or you need to give the position where the substituent group is present. So this substituent group is present in this particular chain at the second position, so you need to write 2 like this. Remember, number and alphabet, there is hyphen like this. You need to give hyphen. Correct? 2. What is the name of this? I think you have done in class 10. So this is actually from methane. After removing one H, this is now alkane. After removing one H, it will form into alkyl group. So this is methane. So this will convert into methyl group. Okay, so the name for this CH3 is methyl group. So at the second position, methyl group is there. Okay, that is prefix done. Okay. So now root name. What is this chain name? Meth, eth, prop, but. This is butane, 4 carbon chain. So this is butane. So 2-methyl butane, butane. So only the first letter is capital. After that, all small. Got it? So this is 2-methyl butane. At the second position, we have methyl group. So this is 2-methyl, and the root name is butane. So there is no functional group. All the functional groups are there. That is why there is no suffix. Or you can write in the same way. We can consider this single bond as functional group. So this is but dash ane. So we write butane. Got it? Okay. After this, I'll give you one more example. Okay. Look at the board. First, you need to select the longest chain. If you check, then this will be the longest chain. Okay, now you need to number 1, 2, 3, 4. These are the subsequent groups. 2 groups are there at second position, at third position. So this is the way of numbering. Or if you wish to number this side from 1, 2, 3, 4. So it is getting 2, it is getting 3. So from both the end, they are getting the lowest possible value. Got it? So now, after selecting the longest chain and after numbering, you need to write the suffix. So there are subsequent groups, so this will be suffix. So now, how to write this? Because we have 2 subsequent groups, so you need to write this 2 is for this. Both the groups are same, so 2 now comma. Okay, between the numbers you have to write a comma. So 2 comma 3. At the second position and the third position, we have this is di. We have 2. That is di. Di is for 2. If 3 nikal together, you need to write tri. Okay. If 4, then tetra, like that. Okay. So now 2 comma 3. This is dimethyl. What is the root name? Meth, eth, prop, but. Butane. Got it? Very, very simple. If you know the basics, you can easily write the IUPAC name. Okay. So from tomorrow or from next class, not from tomorrow, from next class, we will do the naming with compound with functional groups. Got it? Okay. So try to check that PDF and try to have some idea. If you have some idea, then you can easily understand whatever is taught in the class. Okay, so please go to the PDF. Thank you very much for today.